In this practical, we are investigating the effect of light intensity on the rate of photosynthesis, aren't we?
Yes.
So would you like to say your little bit?
If you are enjoying these videos and you have seen multiple of these before, or if this is your first one, please like, share and subscribe, and let us know in the comments if you have done the practical.
Okay.
And there will be free worksheets in the description.
Additional materials?
Yes.
Okay, so here we are starting off a table because we always put results in a table, don't we? And
Yeah.
you can see we've got distance written down here, bubbles of oxygen there. We're going to be trying to count bubbles of oxygen. That's going to be difficult when it gets fast. So it's quite a long-winded practical, so when you do this you'll need to allow yourself plenty of time. So we have set ours up already with our plant in a fairly narrow jam jar. The narrower the vessel that you put it in, the better, but you obviously want to have it. I've attached a paper clip to our pondweed, Elodea.
Elodea.
Yeah. And I did that by opening the paper clip up and slightly straightening it out so that it would go around it. Why did I put the paper clip on it?
So it sinks.
So it sinks and stays down, because it has Elodea has a habit of floating, particularly when it's got lots of oxygen bubbles around it. How do we know it's oxygen?
Because what else would it produce?
There is that, yes. If we wanted to test for oxygen, how would we test for oxygen?
With difficulty.
Really?
We would light a fire.
Well, it really likes a glowing splint, so what we'd have to
Yeah.
do is we'd have to have some kind of delivery tube system. So we
That's
would,
why I say with difficulty.
yeah, with difficulty. So we'd have a delivery tube system which we can make with bendable straws and a hole.
Plasticine.
Yeah, the plasticine was there, so when I stabbed it, I stabbed into the plasticine and didn't bend the lid. But anyway, so with a hole pierced in the lid, you can put we're going to make that a little bit wider, and you can attach the delivery tube to it. But we're going to collect gases another time and test those, okay? So that's something we're going to do another time. But oxygen really likes the glowing splint, okay, or spill, or
Yeah, but
match.
you can't put a glowing splint in water.
No, that's right, you can't. That's why you've got to collect it as it comes off. But unfortunately, something like pondweed is not producing enough of it that we can actually test very easily, although I'm assuming somebody has at some point. So that's how you test for it. You can collect it and test it with a glowing splint and see if it relights it. It doesn't need much more oxygen than baseline oxygen in the air for it to actually relight a glowing splint. We've got 20% oxygen in the air. At around about 30 it would happily relight a glowing splint. So what have we got in the jam jar with the Elodea?
We've got water and CO2.
Water and CO and added CO2, and that's set up 1 metre away. So what we're going to do is we're going to leave that for 10 minutes, and during that 10 minutes we're going to let it acclimatise. After 10 minutes we will spend 1 minute counting bubbles, which we will time using a stopwatch. So do have a stopwatch handy, or a minute hand on a second hand on a clock. Counting bubbles, it's very, very difficult to see the bubbles, isn't it? So what are we looking for when we're counting the bubbles?
Bubbles.
So they're little tiny bubbles rising up, aren't they, through the water. Some of them get trapped around the edge of the leaves, so you have to sometimes count all the ones that are trapped around the edges of the leaves as well.
Yeah.
So when your minute is up, you can quickly go around and count all the bubbles that are trapped on the edges of the leaf and tucked inside the leaves, and include those into your results. Okay.
Yeah.
Now, whilst we're doing this practical, we're going to shut all of the curtains, switch all of the overhead lights off and the extra lighting that we've got for the videoing, and the cooker hood and everything else, and block out the light from the plant using a piece of cardboard. Why are we doing this?
So there isn't extra light shining on the plant other than this one, which is going slowly progressing longer. If we had this light that we've got here on, the 100 centimetres would end up with quite a higher result than it normally would.
Yeah, because basically you'd have light coming in from elsewhere. It wouldn't make it a fair test at all, and it wouldn't help us show what we're trying to show. Okay, brilliant. And let's get on with the practical. we have set the plant up here and we have turned out all of the additional light sources that we normally have on. It is now acclimatising to the light source, one light source only, 1 metre away. And we have got some cardboard set up to shield it from light coming in from another window that we can't block out easily. We've done that for 1 minute with it in that position, 1 metre away, and we got 0 bubbles. How far do you think we should move it for our next reading?
20 centimetres.
Yeah, if we move it 20 centimetres closer, that sounds good. So we'll move it up to 80 centimetres, so have the middle of the jar at 80 centimetres, and we'll go again.
With this experiment at 80 centimetres, we saw 4 bubbles. For this experiment, at 60 centimetres, we saw 8 bubbles per minute. At this experiment with 40 centimetres, we saw 11 bubbles per minute. And at 20 centimetres, we saw 15 bubbles per minute.
So summary of the results is 100 centimetres, 0 bubbles per minute, 80 centimetres, 4 bubbles per minute, 60 centimetres, 8 bubbles per minute, 40 centimetres, 11 bubbles per minute, 20 centimetres, 15 bubbles per minute. Now what we would do at this point is we'd plot those onto a graph. And because that's a continuous graph, we would join all those dots together and form a curve on that graph. Okay, so you can do that at home if you want to. The other thing that we notice is that there's a trend on it. So it starts off, the further the plant is away from the light source, the smaller the number of bubbles.
Yeah, and it also almost kind of doubles.
It does, doesn't it? So we've got, there's a geometric progression going on, so you can look into that as well and have a look at the slope of the curve.
So, thanks for watching, guys. Make sure to like, share and subscribe, and leave a comment if you did the practical, and we've got free resources down in the description.
Okay, brilliant. See you next time.